Okay, we're going into Algebra Module 6 with inequalities. I just have to remind you that if it's an open dot, we're dealing with less than and greater than. If it's a closed dot, it's less than or equal to, greater than or equal to. Now, there's one more thing that also is an open dot, and that is if something is not equal to something. Now, an inequality is a mathematical sentence that contains less than, greater than, less than or equal to, greater than or equal to, or not equal to. An inequality compares the value of two numbers or expressions using the symbols. So I want to talk about this. So there are some of you that will do this. They'll put a 4 here, that's a closed dot, and they'll do this, and I'm going to mark that wrong. Because you can't have a floating dot, and you can't just have one number on the number line. You need to put more than one number on the number line. Now, I personally say at least 2 above and 2 below. It is a closed dot. It says less than, so I'm going to come this direction. And voila. Over here, this is greater than, but that's a half. So if you like starting at 0, that's fine. I'm actually going to go up by halves. 1, 1.5, 2, 2.5, and then go backwards. Negative half, negative 1, negative 1.5, negative 2, negative 2.5. That is an open dot, and that is the numbers greater than. So it goes this direction. Okay, so set builder notation. It represents the set of all numbers such that x is blank to blank. So if I'm looking at an example, this bar right here means such that. So you do your braces, you do x such that x is greater than or equal to negative 4. Now we learned in the other chapter to write it in interval notation like this. The smallest number is negative 4, and it includes the negative 4, and it goes all the way up to positive infinity. So we're going to do this. We're going to solve these. So I'm going to add 10 to both sides. I get x is greater than 25. If I wrote it in set builder, x such that x is greater than 25. If I'm going to write it in an interval notation, I write 25, and it gets bigger, so that's this. It's going to be a parenthesis for sure there, and because it doesn't say or equal to, it's going to be a parenthesis on this side. Solve this one. I add 9 to both sides. I get b is less than or equal to 25. Okay, so I write it b such that b is less than or equal to 25. 25 is the highest number. I want to go lower, so I'm going to go down to negative infinity. But it also includes 25, so it is a bracket and not a parenthesis. Over here, I'm going to subtract 24 from both sides. When I subtract 24 from both sides, I get 37. So these numbers are greater than 30. Oh, let me do the set builder first. X such that x is greater than or equal to 37. Okay, 37 is the smallest number. It's going up and up forever and ever. So there we have it. Now, right here it says if you switch the sides of the expression, then you must change the inequality. Now, the best way and easiest way to do inequalities is to have the variable on the left-hand side and either whatever the inequality is you're using to be in the middle, and then whatever your number is on this side. But if it doesn't come out that way, you can just switch sides. So on this one, I'm going to solve, and I'm going to get, what is that? 75. But I don't want my x on the right-hand side. I want it on the left. So if I switch the sides, then I need to switch the inequality to the other one. If I wrote that in set builder, x such that x is greater than 75. If I wrote it in interval notation, 75 is the smallest number. It's going to go up to infinity, and it's both of them being parentheses. Here, subtract 9y, subtract 9y. 3 is greater than or equal to y. Well, I don't like it like that. I want the y on this side, the 3 on this side, but I have to change the inequality to the opposite. So all the numbers are less than or equal to 3, so 3 is the highest number, and it is included. Oh, I forgot to do set builder. Sorry about that. Y such that y is less than or equal to 3. Okay. Subtract 7x from both sides. Get 6 is less than x, or x is greater than 6. X such that x is greater than 6. And then write that the numbers are bigger than 6, so it's going to be numbers bigger, and it is not including 6. Okay. Hassan's wireless contract allows him to use at most is going to be less than or equal to 5 gigabytes of data per month. At this point, Hassan he's already used this amount of data. How many gigabytes of data can Hassan use during the rest of the month? Okay, so he's already used this amount. He's got more to add to it, but it can't go over 5 gigabytes. So then you solve it. And that's going to be what? 1.3? So x is less than or equal to 1.3 gigabytes. Okay. Solving inequalities by multiplication or division. If you multiply or divide both sides of an inequality by a positive number, then the inequality remains true. If you multiply or divide each side of the inequality by a negative number, then the inequality symbol changes direction. Okay, so let's look at this. Alyssa has read approximately a fourth of the novel. Do we know how many pages are in the thing? Nope. If she has to read at least, so that means it's got to be greater than or equal to 112. So we know it's 112, it has to be bigger than. And a fourth of the novel. I don't know why I wrote a half. A fourth of the novel. I'm going to use n. So multiply both sides by 4 and get n is greater than or equal to 448 pages. Okay. Maybe. I'm going to skip that. Just keep on going. So I don't like having that fraction, so I'm going to multiply both sides by 5 to get rid of that fraction. So I have negative 2x is less than or equal to 55. Okay, so I'm going to divide both sides by a negative 2. Because I divided both sides by a negative 2, the inequality must change directions. 27.5. So if I do 27 here, 28 here, 29, go back 26. Ooh, that should be negative. So glad you guys caught me on my error. Okay, so this would be 27. Still can be 27, negative 27, negative 28, negative 29, negative 26, negative 25. There we go. So negative 27.5 would be here, and it's all the numbers greater than that. Okay, and if I was to do that in set builder notation, negative 27.5, or negative 27.5 to positive infinity, including the negative 27.5. Okay, over here, I divide by 4 on both sides. No, I do not. I divide both sides by 20. And I get 1/5. So if I did 0 here, 1/5, 2/5. Oh, how about I do this? Move 0 over a little bit. Put 0 here and 1/5. 2/5, 3/5, 4/5, 1. Negative 1/5, negative 2/5, negative 3/5, negative 4/5, and negative 1. So I do an open dot at 1/5 and less than. Okay, over here, divide by 7. I did not divide by a negative 7. I divided by positive 7, so negative. Go in there 2 times with 23. There we go. So negative 23, negative 24, negative 25, negative 22, negative 21. Only because I needed space. That's an open dot. It's the numbers greater than, so it goes this direction. Set builder notation x such that x is greater than negative 23 and negative 23, comma, infinity. Okay, so now what we're going to do, we're actually going to come here. Now what we're going to do is we're going to put all of it together. And just like when we had the equal sign, we are going to solve with multi-step. So it says Susie wants to self-publish her comic book. One printing company offers to publish the book for a flat $220 flat rate plus $3 per copy of book. Her maximum budget is $400. So she has to use less than or equal to $400. This part right here, this right here is my slope. This right here is my y-intercept. So that would be 3x plus 225 or 220, and then it has to be less than or equal to 400. So if I was to solve that and get 3x is less than or equal to 180, divide by 3 on both sides. Okay. So the most amount of books that she could buy are 60 books, and anything less than that. Okay, Jamal has $40 to buy tickets to a performance for himself and his friends. He buys $10 membership. Okay, spends $10, and he can buy ticket $5 each. So this right here, this is going to be my B value. This is going to be my M value. So 5x plus 10. And he has $40 tickets. Well, he can't spend more, or $40. He can't spend more than $40. So I said, I divide by 5. Divide by 5. X is less than or equal to 30. Or not 30, 6. So he can buy 6 or less tickets. Then this one says the opposite of a number, negative x, divided by 2 minus 17 is less than, 7. So if I add 17 to both sides, negative x over 2 is less than 24. Multiply both sides by a negative 2. and get x is greater than negative 48. So I come down here to negative 48, and that's an open circle, and it's all the numbers greater than. Okay. So, same thing here, guys. Same thing here. Pretend like you don't see this part. Just do this part. So 8x minus 44. Okay, then we'll get rid of that because we need it. Okay, so then it says less than or equal to the negative 12 plus, and then I distribute here, and I get 2x minus 8. I need to combine like terms. These are like terms. So the left side, nothing happens to the left side. I leave that alone. I would get 2x minus 20. I want the variables on the left-hand side, so I'm going to subtract 2x from both sides. I'm going to get 6x minus 44 less than or equal to negative 20. Add 44 to both sides. Get 6x is less than or equal to 24. Divide by 6. X is less than or equal to 4. Set builder notation would be x such that x is less than or equal to 4, and negative infinity to positive 4, and then I graph it. So I go to 4, I have a closed dot, it's all the numbers less than, and voila. Over here, there's nothing to do on the left-hand side, so I just write the 88. I do need to multiply this through, so I have negative 33 plus 11x plus 88. Combine like terms, and I get 55 plus 11x. Subtract 55. I get 33 is greater than or equal to 11x. I divide by 11. 3 is greater than or equal to x. I don't like it that direction. Set builder. The numbers are less than 3, so it includes 3. So I come to 3, which is about here. And it's all the numbers less than, so I draw an arrow. Okay, then this next part says an empty set of all real numbers. If the inequality simplifies to a false statement, then there's no solution to the inequality. The solution set is an empty set. However, if the values of the variable make the inequality true, then the solution is all real numbers. So if I had x, no, don't do that, minus 12 is less than 2x minus 4 minus x. Okay, so then I get, this would be x minus 4. I subtract x on both sides. Negative 12 is less than negative 4. Is that a true statement? This is a true statement, so that means this is all real numbers. Okay. If I instead had 3x minus 5 is greater than 3x plus 7, subtract those 3 x's, and my answer is negative 5 is greater than 7. That is not true. This is a false statement. So it is the empty set or no solution.